Hey everybody, this is Brad Dyke reaching out to you to say hi. This is me doing a hardware video, and this one's going to be a little different. It's about an approaching technology which has been going on for about 6-7 years now, and it's pretty interesting actually. It's about what we call ultra capacitors, super ultra capacitors basically. These capacitors are really impressive because they are not capacitors like we know them on motherboards. Instead, these are more like batteries. And let me give you an example of what I mean to show you here. Hang on a second. These are basically ultra capacitors. They are very capable, very functional, and these work in farad values, which is a much bigger capacity than that of the traditional normal capacitors we find in electronics, which are in microfarad levels. Now, the cool thing about these guys, and if you see here, these are in a series. That means one is hooked to the next, hooked to the next, to the next, to the next, to the next, until the other end. And this right here is the same thing, but on a PC board. And if you flip it upside down, you'll see here the making points. These are the wiring points and the regulators to create what's called a regularized or voltage regulated output. But the same effect is in the same game here. Now, as you can see also, I'm using heat sinks underneath them here. As you can see, these are heat sinks that use heat pipes, but there's no TED. That's a thermoelectrodiode on them to help increase output of heat to cold, or this would be even more functional. And that these are something of a interesting design because what these are is the equivalency of giving you what's called recursive battery power. So there are versions of these capacitors that are about the size of a pop can, and they're in the thousands of farads. They're very capable and competent outputs that are capable of starting an engine on a car. That we use these quite heavily in the nature of certain types of building UPSs to support what we call a PDU series distribution network. These are in quantity much more functional and more capable than recharging a typical lead acid battery. Now, the cool thing about these types of batteries is they don't take a lot to recharge. So if you have an alternator kind of configuration set up, you can take a huge number of these guys, like for instance, you're powering a windmill, and you feed it to these guys to keep the voltage outputs up high, and then it becomes like a big pool of water. Now, in it is the electrons, right? And at the bottom of the pool, in this particular case, right here, these two guys, are the connection points for the power output. And the draw is, let's say, 6 volts, right? Or it's a 12-volt draw on a 24-volt line. And that basically means that if I'm going to fully charge this up, it's going to give me a lot of power rapidly, or a little bit of power for a long time, like the way a battery works. Okay? So if you were to, for instance, decided to replace your UPS array with a UPS that uses ultra capacitors like these, the ultra capacitors will never, ever, ever run dry. In other words, they won't end. You won't have to replace the battery after so many years. These guys just run indefinitely because they're not batteries. They're capacitors. As long as they get a charge and receive it, and the cohesiveness and the nature of these capacitors are solid, in other words, they're built well, they'll continue to work 20, 30 years later. And that's why one of the big problems I have with this technology is that the industry that made this technology is trying to figure out a way to break it so that they can make more income off of you, because they've made a product that's too good, in my opinion. It really works well, and now they got to make it work not so well so that they can get some return on value from you in a few years later after you've bought their product. Now, to me, the mindset about this is that's not practical, right? Because if you make these subcomponents, we can do a lot with them, and they have done that. But now there's a maneuver in the industry to strip us of the ability of being able to get these in either mass quantity or in a particular kind of configurations, because they want to control how these things are being handled under their agreement sets and basically get control of the market. So what can you do with this really cool gadget? Everything. All you have to have is a continual inbound of voltage load coming in to maintain the batteries, and they don't have to be maintained constantly, unlike other environments. Now, if it was in my home and I could get myself 20 or 30 of the 6000 series, my ultra capacitors, which are pretty decent size, I would be able to create what's called a load feed, that all the electricity that comes into my house, may it be solar powered, wind generated, or from the electric grid, would never touch anything in my house. They would hit a voltage regulator. The voltage regulator would send that whatever source of electricity into something like this on a big scale, and this will be the home for my electricity. Everything I have in the house connects to this only. The regulator interface is connected outside my environment and allows for that kind of setup to happen. Now, I can do two things. One, not such a big benefit in my opinion. If I have excess electricity, I could send it right back out through the electrical output and get paid by the electrical company for using my electricity on its grid. That's selfish. That's just, you're looking for money. I'm not. What I'm looking for is a good quality source of electrical energy that's highly controlled and localized. In other words, just like the way a UPS works, right? The power comes into the UPS and is converted to DC and then sent to the battery. On the other side, where you plug in your equipment into the back of the UPS, is a voltage regulator that converts the DC voltage from the battery back into AC alternating current to supply power to your units. And as long as you've got incoming voltage, the battery is just doing its job and acting as a buffer. That's value number one. You haven't lost power yet. Now what you've done is you've conditioned your voltage load so that it's 100% secured. Now, a little warning for those who use a variable capacitor between your 100 amp and your 100 amp in your CPC box or your main breaker box. Understand that when you cross that, to create what's called a closed loop effect on your two different providers of 100 amp power, that could be messed with a little bit. So how do you fix that problem? Real easy. What you do in a nutshell is you continue to keep your configuration in your main circuit breaker box the same way, but you pull the two 100 amp block loads off to a second circuit breaker box that strictly only sends power to the your local home conditioner. Now, another little bit of information you need to understand, that when you do this separation between church and state, in this case, separating the use of electrical energy in your house from the electrical grid, you have literally cut off the electrical grid. What am I saying? Okay, you've heard the adage that you can use your electrical wiring as a network. Not only is it known, it's in process right now. There's a lot of communication that exists on our electrical grid because it's just another media to run a network communication protocol on. You can take these small gadgets and plug them into your wall sockets and put an RJ45 network Cat5 connection in it, go somewhere else in your house, and if you're wide open, you can go to the next guy's house, plug in another one, plug it in, and you'll be able to see each other in two different locations. Why? Because the wiring of the main grid comes into the primary grid. Now, I paused the video for a second to bring you guys an example of what I'm talking about. So here's a classic surge strip, right? And you think that when you plug this little plug in, it's going to do whatever you want it to do. And what you're not aware of is that is an open wire. So as far as you're concerned, if you did plug in a network RJ45 transceiver plug into one of your walls or into your surge strip, it will travel down all the physical interface wires that it can get to, including running through the transformer lines between homes to other homes. So it's an interesting little prospect that exists, and it can actually interact in certain ways. It probably is not something you want to really know about, because personally, in my opinion, I think it's kind of, how would you say it? Not intrusive. It's just kind of odd that you could potentially do this. Now, the use of using local networking connectivity on a power grid is not a great idea. This is why it didn't take off very well. The reason why is because anything that receives a static discharge or an EMP pulse, it's any form of electromagnetic pulse, including lightning, would have more effect on more equipment for anything that's physically connected to it by wire. So that's why we separate the networks from the electrical nature of the environments, because we don't want all that wiring going, getting shocked and blowing out thousands of dollars worth of equipment. So we don't use network wiring as a functionality with local AC current house power outputs. So what I mean by that is when you break away that 200 amp box and it no longer feeds the house directly, it goes into a UPS of sorts, a big one, that's going to have a two 100 block amp feeds coming up out of it and going into your main breaker box, and that's the guy who provides you power to your house. If you lose power from the external source, you still have power coming in from, let's say you have a wind generator, or let's say you have solar power. Those would charge these super capacity ultra capacitors very quickly and keep them charged. And since it's a big pool of water, right, in your sense, a pool of power, and in the bottom's a little hole, not a big hole, a little hole called 120 volts and 15 amp loads, that all that water will slowly go through that power hole until you run out of power. Then you're actually genuinely out of power. But the really super cool thing about these guys is, unlike a lead acid battery or even a lithium ion battery, these just take minutes to recharge. They're really easy to recharge, and they can do it indefinitely. So that's really cool. So the next thing you want to do is take a look at this. Let's see if I can do this right. Yeah, you see those right there? Those little black chips? So it's chipset? Okay. Now that's intelligence used to help make this voltage load more functional. And I built this board as an experiment for myself because I was really enthralled with it, but I was kind of unhappy when I saw that they were trying to monopolize the nature of this technology, just like EMC did with storage capacities, and just like with other companies like Apple and Solaris and so on. I wasn't very pleased with that, so I kind of backed off of this technology. But you can build these pretty effectively for a really good cost-effective nature, building some programmable logic, and then use what's called a analog to digital converter analysis tool for AC-DC conversion, and you would have your ability to track and maintain the health of your electrical grid system. Now, you can do that by just simply buying a store-bought wattage checker, that you can put in as a break between the main power source and your secondary source that's providing power to your system. Actually, I would do two, one before and one after, because you want to know how much juice you're pulling off of the main grid separately from what's being provided through your normal internal system. And like I said, if you put in a wind generator or you put in some other form of electrical generated current, such as solar power, those would complement the returns, and you can prioritize which one gets to feed power to your ultra capacitor battery packs. And with that being said, you now have yourself a new innovative way to answering an old question of getting your electrical power as you need. Down the road, Tesla kind of approached this, but they wanted to tout lithium ion. My recommendation personally is that if you have a combination of both battery and ultra capacitors, what you do is you charge the batteries, right? You have, let's say, lithium ion, or you have a lead acid battery strategy, and they get charged by AC/DC current outputs, and that means both solar power, wind generators, and your main line. Now those guys will power your high power ultra capacitor block, and you think, well, what value is that? Well, here's how. When the pool of water is so big, that's your defining factor. You've got a small hole here in the bottom called 120 volts, 15 amps, and you're letting the electrical waters flow down into that. But what you don't realize is right above that pool of water is another larger pool of slower chargeable electrical energy that can then quickly recharge the pool and keep putting more power back into the pool of water, and flooding it more with water and water and water and water until that source becomes depleted as well. Now above that is your actual target, which is your 120 volt input from 2 block 20s, or in this case 2 block 100s to be exact, which is giving you your 200 amp output. That allows you to be able to really create a multi-tiered power grid system for your home. Now it's not big. It surprisingly is a pretty small device. Your batteries, if you choose to add them to the ultra-capacitors, would be much more sizable than the actual ultra-capacitors would look like. That's why I'm saying it's quite surprising how condensed this is in general. But if you're a big fan of really good current, and that's important, by the way, for your IT gear, using line conditioners and feed systems and UPSs and so on is an excellent way to support power to your systems. Or you can clean up all the current and have clean current at your 200 amp block, and that would keep all of your household appliances, anything that's digital, in a very good place. Now, the last thing that's a very, very, very critical here is you're going to have to realize anything that uses what we call a two-prong connection is a real risk. So what I mean by that is if you have just 2 out of the 3 contacts in an electrical outlet, then you have a device that's not grounded. So what do I mean by that? Well, we have different types of surge strips. I'm going to see if I can find one here. Yeah, here we go. Here's an example of one right here. This is what I'm talking about. 2-plug. Now, the danger of 2 plugs is if something happens to the device, there's no way to properly discharge, and you run the risk of frying the electrical system that you're working with. May it be a charger or something simple or something complex like a computer. So I always tell people, always gravitate to something that uses positive, negative, and ground, and have a truly naturally centralized grounding of your home. Not a 2-part grounding. In other words, you got a ground rod on one side of the house and ground rod on the other. Don't tap into the house grounding wire for the electrical wire that might run to your ceiling. That would run to your roof. That would be used to as a lightning rod to divert lightning strikes away from the other part of your home. You don't want to do that. That's not a good answer. What you want is you want to have a direct ground put into the ground that goes directly into your main box. It will go into your main CPC charge unit, and it will also be there for your 100 block inputs. Grounding is critical. You got to have it. With that being said, there are a couple of discussions you could technically do. Like, for instance, you might want to separate the ground from the 2-block 100s come in from the street and give that a natural ground all by itself. And then you can run the internal battery / ultra capacitor system and your local panel off of one common ground neutral separately. You can do that. If you have a generator added to this equation, like a propane generator, which is a recommendation, natural gas input / propane supportable generator, which means you can use natural gas from your house, or if you need to in emergency, put a propane tank on it and it will run off of propane. A little bit of difference, loss in performance for the generator, but they both work. So with that being said, if you do that, you would want to definitely isolate the generator's ground away from everything else, because it's just like the 2-block 100s. It's a smaller load of voltage, but it has to come into your primary battery ultra capacitor setup. Well, this is Brad Dyke. I wanted to talk about infrastructure support for electrical powers this time because I have people asking about it, and introduce to you guys some really cool, neat technology that just really is innovative. It can make you think outside the box, and get away with doing some really cool things and get rid of those god-awful battery-powered UPSs. Maybe build your own little ultra capacitor version insert for your UPSs and run off of ultra capacitors instead of batteries. Hey, sky's the limit. My rule. Reinvent, think outside the box, turn something old into something new. Well, this is Brad Dyke signing off. God bless, and you guys have a great week. Take care.